Welcome back to the Tech Talks podcast, where we delve into the intriguing realm of technology, software engineering, and the principles that keep our digital lives functioning seamlessly. Today, we're focusing on a vital aspect of distributed systems: consensus. Whether you're a seasoned developer or simply curious about how systems come to an agreement on data, this episode will unravel the complexities of consensus algorithms, their evolution, and how they're applied in the real world. So grab your headphones and let's jump right in. In distributed systems, multiple computers collaborate to achieve a common objective. But how do these systems agree on their current state, especially when failures or network issues arise? That's where consensus becomes essential. Consensus algorithms ensure that all nodes in a distributed system can agree on a single value or state, which is crucial for maintaining consistency and reliability across the board. The idea of consensus in distributed systems has been around for quite some time, with Leslie Lamport being a pivotal figure in its development. His influential paper, The Part-Time Parliament, introduced the Paxos algorithm, which has since laid the groundwork for many modern consensus protocols. Paxos was designed to tackle the challenges of achieving agreement among a group of unreliable nodes, making it a cornerstone of distributed computing. Paxos is often regarded as the gold standard for consensus algorithms. It functions through a series of phases where nodes propose values, accept those proposals, and ultimately reach a consensus. However, implementing Paxos can be quite complex, leading to various interpretations and adaptations. For example, Tushar Chandra and his colleagues presented Paxos Made Live, which discusses practical implementations of Paxos in real-world systems, shedding light on both its challenges and successes. While Paxos is robust, its complexity can pose a barrier for many developers. That's where Raft comes into play. Introduced by Diego Ongaro and his team, Raft simplifies the consensus process, making it more comprehensible and easier to implement. Raft organizes nodes into a leader-follower model, where a leader node manages the log of entries and coordinates the agreement process. This shift has made Raft a popular choice for developers seeking a more intuitive approach to consensus. As the landscape of consensus algorithms has evolved, researchers have conducted comparative studies to assess their effectiveness. For instance, Robert Van Rennes and his colleagues analyzed Paxos, view-stamped replication, and ZAB, highlighting their respective strengths and weaknesses. Each algorithm possesses unique features, and the choice often hinges on the specific requirements of the application, such as fault tolerance, performance, and ease of implementation. Consensus algorithms aren't just theoretical concepts. They have been implemented in various systems that underpin our digital infrastructure. Take Apache Zookeeper, for example, which utilizes an atomic broadcast protocol to maintain configuration information and synchronization across distributed applications. Will Portnoy shared his experiences with implementing Paxos, emphasizing the practical challenges he faced and the importance of grasping the underlying principles. The field of consensus algorithms is still evolving, with researchers continuously exploring new ideas to enhance performance and flexibility. For instance, Heidi Howard and her colleagues introduced Flexible Paxos, which revisits quorum intersection to boost the efficiency of the consensus process. Additionally, the concept of evaluating consensus at the Internet edge has gained traction, as highlighted in the work of Howard and Crowcroft, suggesting a shift toward more decentralized approaches. In today's cloud-native environments, where microservices and distributed architectures have become the norm, consensus algorithms are critical. They ensure that services can reliably communicate and maintain consistent states, even amidst failures. As Camille Fournier pointed out in her talk at the Craft Conference, understanding consensus is essential for architects aiming to build robust and scalable systems. To sum it up, consensus algorithms form the backbone of distributed systems, allowing nodes to agree on shared data and uphold consistency. From Leslie Lamport's foundational work with Paxos to the more accessible Raft algorithm and ongoing innovations, the journey of consensus is both rich and complex. As we continue to push the boundaries of technology, understanding these principles will be crucial for anyone involved in software development and system architecture. Thanks for tuning in to this episode of the Tech Talks podcast. We hope you found this exploration of consensus in distributed systems enlightening. If you enjoyed this episode, don't forget to subscribe and leave us a review. Until next time, keep questioning, keep learning, and keep innovating.